Good evening. My name is Patricia O'Reilly, and on behalf of the Jesuits of Canada and Jose Sanchez, our Director of Communications, I welcome you to our talk tonight, Peru to Mars, New World and Jesuit Science. Our talk will be about 60 minutes, and then we'll have questions and answers. We will prioritize the questions as they come in. The session will be recorded and posted on the Jesuits of Canada website. I'll turn it over to Jose for some technical and translation details.
I will switch to French for this, just to give instructions on how to access the French track. Alors, pour choisir la langue de votre préférence, si vous êtes sur un ordinateur, dans les commandes de votre webinaire, cliquez sur Interprétation, le bouton Interprétation, et cliquez après sur la langue que vous souhaitez entendre. Si vous êtes sur un appareil mobile, dans le contrôle de votre réunion, appuyez sur le bouton avec les 3 petits points ou plus, et après appuyez sur Interprétation de la langue. Et finalement, appuyez sur la langue que vous souhaitez entendre. C'est important de se souvenir que l'interprétation linguistique n'est pas disponible lorsque vous accédez à Zoom sur un navigateur mobile. Désolé, sur un navigateur web. And I'll switch to English for this. Remember, you can ask questions, as Patricia said, through the question and answer button, also at the bottom or top of the screen, depending on the device that you're on. And the questions will be answered, as Patricia said, towards the end of the session and will be prioritized. Another reminder, a recording of the session will be shared by 48 hours after the event via email. 48 hours. And if you have technical problems, feel free to reach me through the chat box, the button at the bottom of the screen, or if the chat box is already loaded, on the right side of the screen. Thank you. Over to you, Patricia.
We would like to begin with a land acknowledgement. We acknowledge the indigenous peoples of all the lands that we are on today. While we meet today on a virtual platform, let us take a moment to acknowledge the importance of the lands which we each call home. We do this to reaffirm our commitment and responsibility to improving relationships between nations and to improving our own understanding of local indigenous people and their culture. From coast to coast, we acknowledge the ancestral and unceded territory of all the Inuit, Métis, and First Nations people that call this land home. We acknowledge the harms and mistakes of the past and commit, each in our own way, to move forward in a spirit of reconciliation and collaboration. It's my pleasure to tell you a little bit about our speaker tonight. Brother Guy Consolmagno, Society of Jesus, is the Pope's astronomer, the director of the Vatican Observatory, and president of the Vatican Observatory Foundation. He is a native of Detroit, Michigan, not too far from us, here in Toronto. And he earned his undergraduate and master's degrees from MIT and his PhD in planetary science from the University of Arizona. He was a researcher at Harvard University and MIT. He has served in the US Peace Corps in Kenya and taught physics. And then he decided to join the Jesuits in 1989. At the Vatican Observatory since 1993, his research explores connections between meteorites, asteroids, and the evolution of small solar system bodies, measuring meteorite physical properties in Castel Gandolfo and observing distant asteroids with the Vatican's telescope in Arizona. Along with more than 200 scientific publications, he is the author of 6 popular books, including Turning Left at Orion with Dan Davis and Would You Baptize an Extraterrestrial with Paul Mueller. They're great titles. He has served as chair of the American Astronomical Society Division for Planetary Sciences and as president of the International Astronomical Union Commission on Planet and Satellites. The International Astronomical Union has given asteroid 4597 the honor of bearing his name. In 2014, he received the Carl Sagan Medal for Excellence in Public Communication in Planetary Sciences. Each January, he hosts a faith and astronomy workshop in Arizona, and hopefully he will have a little time to tell us a little bit about it. Brother, welcome and thank you for being here with this evening. And I'll turn it over to you, Guy.
Thank you very much. So if I've done this right, people should now be able to see the first screen. Is that correct? With the title. Wave if you can see the first screen. I just want to make sure it's right.
Yes.
Fabulous. Thank you. The talk I'm going to give today is really a historical talk, and I'm not a historian. So I wanted to acknowledge the people, the historians who have helped me gather a lot of this material, including my friend and co-author, Paul Muller, along with Chris Greeny and Ileana Kenichi, all of whom have worked in the history of astronomy. In the autobiography of St. Ignatius, we read that the greatest consolation that he received was from gazing at the sky and the stars, and this he did often and for quite a long time. So from the very beginning, the Jesuits had a certain interest in astronomy. But in fact, the Society of Jesus is dedicated to being close to Jesus. Jesus is God's incarnation in the physical universe. And the first Jesuits were a group of men who'd met at the University of Paris. Scholarship was an essential part of what formed them as a society. The unity of hearts and minds came from being students together. And this scholarship from the beginning was at the highest university level. And it included expertise in all the subjects of the university, not only theology and philosophy, but the subjects of the medieval quadrivium, which were mathematics, music, geometry, and astronomy. The heart of Ignatius's spirituality is found in the spiritual exercises. And these are a series of prayers whose common theme is to place and identify God's presence in the physical universe, in specific times and places in salvation history, in our own personal histories. And the exercises begin with what you see here, an outline of what's called the principle and foundation. Notice what's common in each of these principles. Created things. We are created. We are things. All the things of the world are created. Created things can lead us to God. And any created thing that doesn't lead us to what God calls us to be isn't necessarily evil. It's just something that you can ignore. It can be indifferent to. The spirituality of the Jesuits is all about our place in creation, why we're created, why the world's created, how we relate to creation. And this leads to the famous Jesuit mantra, to find God in all things. Being close to the created world is a way of being close to the Creator. And so it's not surprising that science plays an important role in the apostolates of the Jesuits. One of the early examples of this is Father Jose de Acosta, born in Spain in 1540, which was the year the society was founded. He entered the Jesuits when he was 13 years old. In 1572, he was sent to America as part of the third Jesuit expedition. And he stayed there in 15 years, traveling to Peru, Bolivia, Chile, Mexico. And then he went back to Spain in 1587. He had a bunch of university posts, played an important role in the diplomacy between King Philip of Spain and the Pope and the Jesuits. Eventually, he wound up as the rector of the Jesuit College in Salamanca and died in 1600. When he was back in Spain, he wrote a number of books about his experiences in the New Worlds, most notably De Natura Novus Orbis, on the nature of the New World, which was a description of the flora and fauna of the Americans. And that book then was translated from Latin into Spanish, and it led to a series of 7 books that were published collectively as Natural and Social History of the Indies. The first 3 books are about geography and climate and geology, including descriptions of earthquakes and volcanoes. The 4th book talks about minerals and plants and animals. And the final 3 books are about the peoples he encountered in Peru and in Mexico. Now, just having a systematic description of the physical and sociological setting of the New World would be remarkable. But these books are more than that. First of all, notice that it's written in Spanish. This was a generation before Galileo. This Jesuit author is writing in the vernacular, and he's popularizing the sciences. He's spreading it to an audience beyond that of the scholars who would be able to read Latin. And it goes beyond that. There were other authors who'd written about the unusual and strange things you find in South America. But Acosta writes, and I quote, "Till now, I have not seen an author who dares to find the causes and reasons of the new and strange things of nature, natural things which fall outside the generally accepted philosophy." He's going outside the tradition of Aristotle. For example, the jungles that you find at the equator in South America, they're the exact opposite of what Aristotle said you're going to find in the regions near the equator. He said they should be extremely dry and hot, like the Sahara. Acosta says of Aristotle, he was a great philosopher, but he was wrong on this point. Acosta discussed the origins of these things. He discusses the origin of the trade winds. We know the trade winds are tied to the rotation of the Earth, but Acosta attributed them to the rotations of the celestial spheres that were thought to carry the planets. Acosta noted the uniform motion of tides in both the Atlantic and the Pacific, and he attributed this correctly to the action of the moon, which is something Galileo didn't get right. He was among the first to describe altitude sickness. He was the first to suggest that the indigenous peoples originated from Asia and came to America via a land bridge between the Americas and Asia. And this was long before the area around the Bering Strait was explored. Another early Jesuit working in science was the mathematician Father Christopher Clavius. He was instrumental in promoting mathematics as an important part of the curriculum in the Jesuit schools and eventually all the schools in Europe. He wrote textbooks that were used throughout Europe. He wrote these textbooks that were actually even used in mission territories. He's probably best known as part of the commission organized by Pope Gregory XIII for the reform of the calendar, the Gregorian calendar. Among other things, the calendar reform included a new way of calculating the date of Easter and all the other movable feasts that depend on Easter. The reform was promulgated in 1582. 20 years later, Clavius issued a book explaining the reform in great detail, including coming up with tables for the dates of Easter and the other feasts that would be valid up to the year 5000. This page shows the dates of Septuagenima and Ash Wednesday and Easter and the Ascension for the years 2021 and 2022, unimaginably distant, I'm sure, when he wrote the book. Galileo was of the generation ahead of, Clavius was of the generation ahead of Galileo. But in fact, they did overlap and they corresponded. Clavius actually wrote a letter of recommendation for the young Galileo. And he actually was able to see Jupiter and Jupiter's moons through Galileo's telescope. And in fact, the Jesuits were among the early numbers of Galileo's supporters. Unfortunately, a rivalry for precedence using the telescope eventually led to a falling out. And notable in this regard was a dispute. I mean, there are many Jesuits who are in dispute, and I can't possibly go into all of them, but I want to concentrate on Father Orazio Grassi. Grassi and Galileo had a disputation on the nature of comets. Grassi observed the comets of 1618. There were 3 of them that year. He observed them with a telescope, the first to see them with a telescope. And he compared the position of the comet that he observed on a particular night compared to the other stars with what other Jesuit colleagues in Germany saw the same night compared to those stars. he determined that everybody was seeing the comet in exactly the same position, which meant there was no parallax, unlike, say, the moon. Therefore, the comets are located far beyond the moon. And that was difficult to reconcile with the Copernican system, because Copernicus still assumed circular orbits around the sun. Over the next 4 years, Galileo and Grassi engaged in this battle of booklets arguing the point. The interesting thing is Galileo actually never saw the comets. He was sick when the comets were available. The final book was Galileo's book, The Assayer. It was his masterpiece of the philosophy of science. He argued in Italian for a popular audience with great wit and sarcasm how your science must rely not on the authority of some sage, but only on the data. And then in the absence of data, since he never saw the comets, he asserted that comets couldn't possibly be orbiting out in the planets, but that's another story. But it is important to remember that the scientific evidence in favor of the Copernican heliocentric system was not nearly as strong then as it would be in later years. Jesuit scientists were among those who worked the hardest to look at the Copernican cosmology from a scientific point of view. And one of the most notable of these efforts was Giovanni Batista Ricci. 20 years after Galileo, he wrote in this Italian book of more than 80 arguments for and against the heliocentric system. And if you want to know about those arguments in great detail, I refer you to this book by Christopher Graney, an adjunct scholar at the Vatican Observatory. Because the point is, observations of the planets alone cannot distinguish the Copernican system from the Tycho Brahe system. Because in the Brahe system, all the planets are orbiting the sun, but the sun still orbits the Earth. And indeed, all the proofs of that time seem to indicate that the Earth didn't move, didn't spin. They couldn't see parallax, they couldn't see the Coriolis force that the Earth's spin should give them. It's because both of those effects are very, very tiny and hard to see. But they assumed it to imply that the Earth wasn't spinning. The one thing that this book is most remembered for is Ricci's famous map of the moon. And that's where he invents the nomenclature we still use today. He names craters for prominent scientists, including Tycho, including Clavius. Here you can see that the most prominent of the craters he has named for Copernicus. And it sits among other craters who are named for other prominent supporters of the heliocentric universe. Actually, in that place, he also has craters named Ricci for himself and Grimaldi, his student. In fact, he names 24 other craters after Jesuits. The naming of features of planetary surfaces that we follow today follows many of the patterns that Ricci set up, including involving Jesuits and Latin grammar. As it happens, I currently serve as the chair of the Mars Task Group of the International Astronomical Union's Working Group on Planetary System Nomenclature. They think I know Latin. Actually, I know Jesuits who know Latin, which is actually good enough. And a contemporary of Ricci was Athanasius Kircher. And he's a strange and wonderful guy. He was the youngest of 9 children. He entered the Society of Jesus when he was 14. He came to the Roman College in 1633, which was the year of Galileo's infamous trial. Kircher was a great supporter of what he called the new method of philosophy. And that was based on observation and experiment, the way that Galileo's Assayer had pronounced. In this, he was actually an odd mixture of the old and the new, because he would use reason and mathematics to address a question in 3 volumes, determining how Noah was able to fit all those animals on the ark. He was a real polymath. He published dozens of books on topics like hieroglyphics, magnetism, sundials, optics, acoustics, music, astronomy, philology, logic, Chinese culture, Roman antiquities. And he organized this museum that came to be known as the Museum Kircherianum, of Kircher things. But really, his most important role was compilation and publication of the works of other scientists, because this was in the years before scientific journals. So if you're a scientist and you want to tell people something you've discovered, you would write letters to certain individuals who acted as the clearinghouses or the distribution nodes for scientific communication. Kircher was among the best known of these. There are others, Marin Mersenne, a French friar of the Minim Order, and Robert Hooke, an early member of the Royal Society. Kircher's books, therefore, are this fascinating melange of observation and theory. Some of it's outstanding, some of it is utterly absurd. He presents all of it without evaluation or comment. His duty, he thought, was just to communicate the information, not to judge it, not to censor it. A generation later, Roger Boscovich was maybe the most outstanding Jesuit scientist and engineer of the 18th century. And it's an interesting time. The Jesuit General Congregation 16 was held in 1731 when Boscovich was 20 years old. It emphasized the need for Jesuit schools to support the Aristotelian system. That's what the church wanted. Aristotelian's philosophy, or Aristotle's philosophy, was the basis of the prevailing Catholic system of theology. So, you know, if you found Aristotle wrong in one thing, what is that going to do to the rest of your theology? But the General Congregation also opened the door to possibly teaching experimental sciences as well. And pretty soon, Jesuit schools used this as a license to teach Newton's physics. And that's the system that Boscovich was raised in. As a young man, he observed the transit of Mercury, the passage of Mercury across the face of the sun, 1736. And as a result of this, he was active in promoting the observation of similar transits of Venus in 1761 and 1769. We'll come back to those. But his first fame really came in Rome in 1742, when he proposed and directed the repair of cracks in the dome of St. Peter's. And that gave him a certain cachet and a certain prominence among the Vatican officials. So he was among those who worked hard to have the Vatican lift its prohibition against teaching the heliocentric system, which finally occurred in 1757. Among his many works, the most notable was the Theoria Philosophiae Naturalis in 1758, and it's generally credited as the origin of the modern atomic theory of matter. 1760, 3 years after the Copernican system was finally accepted by the church, this was the ceiling painted in the mathematics room at the Jesuit College in Prague. You notice how the little angels are looking through telescopes at the stars, and each star is surrounded by planets and comets. This, dates back to 1760. Among Boscovich's activities are promoting observations of the transits of Venus, and this was possibly the most important scientific achievement of the 18th century. Because you see, if you measure the path of Venus across the sun in many different precisely measured locations on Earth, you can triangulate among those the difference between the Earth and Venus compared to the distance between one observation point and another, which you could measure in kilometers or miles or whatever your measuring system was going to be. And from that, you can work out the distance from the Earth to the sun and the Earth to all of the other planets. And this is the first rung of what's called the distance ladder that allows you eventually to measure the distances to the stars and then to the galaxies and the Hubble scale and the expansion of the universe. It all starts with these observations in 1761, 1769. At the time of the transits, a quarter of all the observatories in Europe were run by Jesuit priests. And one of the most prominent of these was at the Vienna University, and that was founded by Father Maximilian Hell, 1755. In 1769, he led a transit expedition to Lapland at the invitation of the King of Sweden. And this was at a time when otherwise it was illegal for Jesuits to set foot in Sweden. But his reputation as a scientist was such that the king was happy to invite him. Well, of course, it was only a few years later, 1773, when the Jesuits were suppressed. The observatory was taken over by the state, and in the following decades turned over to lay people who are often very anti-clerical. So about 50 years later, 1835, the director of the observatory then, Joseph Johann von Littrow, looked over the notes that Hell had left behind, and he accused Hell of falsifying his data. The publication of Hell's observations of the transit had been delayed for, all the usual reasons. And so they came out after the first results from other people were already calculated from other observations. And Littrow decided that Hell's observations were too good to be true. Indeed, Littrow announced that the ink used in these entries was of a different color, indicating to him that some of the numbers were written in at a later time. And so for the rest of the 19th century, this was kind of the received wisdom. Hell was a fake, but what do you expect? He was one of those duplicitous Jesuits. Except, as you can see in this article here, by the eminent American astronomer Simon Newcomb in the monthly notices of the Royal Astronomical Society, 1883, Newcomb examined the pages with the supposedly different colors, and he writes, this writer was perplexed to find himself differing entirely from the conclusions of Littrow. And then he found out that Littrow was, in fact, colorblind. There is a certain irony here because actually Newcomb himself was often accused of trying to destroy the careers and reputations of his rival scientists, to the extent that some people identify Newcomb as the model for the evil Professor Moriarty in the Arthur Conan Doyle Sherlock Holmes stories. However, arguably the most notable of all the Jesuit scientists is Angelo Secchi. The centennial of his birth was in 1818, and that's led to the publication of a lot of books about him and his science. I was a co-editor of one of them, and his output was remarkable. He built the first electromechanical device to record data of weather. He set up a system of weather reporting using the telegraph. He provided practical applications of science to civic life, from timekeeping to drainage in cities to standards for reinforcing buildings against earthquakes. He founded the first magnetic observatory in Italy. He invented the Secchi disk, which is still called that, to measure the transparency of waters like ocean water. He wondered about the origin of hail and other weather phenomenon. He installed sundials and lighthouses in the Papal States. He surveyed the Appian Way. He played a key role in revising the metric system, and arguably, he invented the fields that we now call astrophysics and planetary sciences. And he did all of this during the turbulent political times of Italy in the 1850s through the 1870s, and died young at the age of 59. If I can indulge myself in showing you a few of the things that, to tell you a little bit more about him. He was born in a middle-class family, entered the Jesuits at 15, taught physics in Loreto, went to the Roman College in 1844, was ordained in 1847. But the 1848, the next year, was when all these revolutions occurred throughout Europe. Garibaldi's armies enter Rome. Pius IX is forced to flee. The Jesuits are expelled from Rome. Secchi is in exile. He spends the next 6 months in Stonyhurst College in the north of England, where he worked at the observatory and learned astronomy. And then he went to Georgetown University in Washington, where he taught astronomy. Finally, the next year, the French army kicks Garibaldi's army out. Pius IX comes back to Rome, and Secchi is installed as the new director of the observatory when he's 31 years old. The first thing he does is to build telescopes on the roof of the Church of St. Ignatius. This is this beautiful telescope that Mertz built at the time. This photograph is from 1904. It shows the observatory still with the telescope in place. It was only moved eventually by the Italians and was lost in a fire. That's actually what the site looked like in 2001 when I visited. And that's the horizon you can see. It's elevated above the surrounding city. And of course, back then they didn't have city lights, but you can see the Pantheon and in the distance, St. Peter's. Secchi studied the sun. He went to observe solar eclipses. He was one of the first to photograph it, and he showed that the corona in his photographs matched those of photographs taken elsewhere, showing the corona was actually attached to the sun and not just something in the sky. He made detailed observations of sunspots, and he recognized the connection between solar activity and the Earth's magnetic field, which is really important when you consider how the Earth's magnetic field controls electromagnetism and power grids and transmission of radio waves, transmission of even cellular towers. In order to keep track of that, NASA has built the 2 spacecraft to observe the sun, and the instrument package that measures the heliosphere is called the Sun-Earth Connection Coronal and Heliospheric Investigation, or Secchi package. There's fame when you get something by NASA named for you. The most remarkable achievement, probably, though, was his observing the spectra of stars and classifying them by their spectra. So let me give you a little of a background about this. In the mid-1820s, Fraunhofer had taken spectra of the sun and the bright star Sirius, and he noticed that they were different, but basically he never followed up on this. Common wisdom before then was that when you do astronomy, you're studying the positions of the stars. You're not doing anything else except seeing where the stars are and how they move. Bessel, one of the great astronomers, 1832, writes, "What astronomy must do is always clear. Lay down the rules for determining the motions of heavenly bodies. Everything else is not of interest." 1835, the French philosopher Comte says, "Every research in relation to stars, not reducible in the end to simple visual observations, is barred." We could never study, for example, either their chemical composition or their mineral structure. Well, with spectra, you can do exactly that. 1859, Kirchhoff and Bunsen shows how the missing dark lines in spectra allow you to relate what chemicals that the light has gone through. So Secchi follows this up by putting a big prism in front of the lens of his telescope, and then every star he looks at becomes a rainbow. And then he systematically observes 5,000 stars. He classifies them by their spectral lines. He notes the difference between stars whose spectra are filled with lines and those that are lacking lines. He notices which of those whose line positions are significantly different from the sun's, but the same as what you see in the lab when you're looking through carbon. We now call them carbon stars. When Secchi's making these observations, he's changing the question of astronomy from where are the stars to what are the stars. And this classification of stars eventually leads to the Hertzmann-Russell diagram, to the basis of everything we do in stellar evolution, basically everything we call astrophysics. And he did the same sort of asking, not only where, but what, when he observed the planets. He got spectra for the atmospheres of the outer planets and discussed the nature of the clouds in Jupiter. And most famously, he looked at the dark markings on the surface of Mars, and he used the Italian word canale to mention those. The things he observed were real, but the word canale would later on be misappropriated by Schiaparelli and Lowell for things that were only optical illusions. The canale of Secchi were real. So 1870 comes along, and his observatory is confiscated by the new Italian government. Secchi has to give up his chair in astrophysics at the Roman College. He's refused the positions that the new anti-clerical government wants to give him because Secchi's reputation in Europe is so great, they're afraid to fire him. Finally, in 1876, the government confirms him as reconfirms him as the director of the observatory, but it's 2 years later, he dies of stomach cancer. And this is the note in Schiaparelli's observation notebook. On the night of February 26, while I was making these observations at 7:15 Rome time, Father Secchi died. Thus has Italy been deprived of its principal and most distinguished astronomer. One final word about Secchi, because this turns out to have a real bearing on astronomy and science as done by the Jesuits in the future. As I said, Secchi had this international reputation. For example, in 1867, at the Paris World's Fair, there were exhibits from every nation in Europe, including the Holy See, which was still a nation then. And his machine, the metrograph that records weather, won the gold medal. Secchi was awarded the Legion of Honor by Napoleon III. A French contemporary commented that without Father Secchi, the Papal States really wouldn't have had much else to show. Secchi himself writes in his diary, "Hurrah for religion in the cassock. That was today crowned rather than me." Also, in 1867, a group met to reform the metric system. They wanted to redefine the meter. A commission was formed. Every nation was invited to send a representative. They would vote by nations. In 1870, the Committee of 1870 was formed, and Secchi is nominated to play a key role. But soon after that, Napoleon III falls. The French army is pulled out of Rome to defend Paris. Italy moves into Rome. Italy declares that the Holy See no longer exists. The Pope insists that he's just a prisoner in the Vatican. So 2 years later, the Committee of 1870 meets again, and they express the wish that in spite of the changed conditions of the Holy See, they wouldn't be deprived of the personal contribution of Father Secchi. If Secchi's allowed to continue his work, it would be a de facto recognition of the Holy See as a nation independent of Italy, which is what the Pope insisted on, but the Italian government refused to admit. So there was a telegram from the Italian minister to the French foreign minister. Father Secchi was here to take part in the work of the commission, received as a representative of the Holy See. Please make known to me if there is a place to ask for explanations from the French government to express our reservations. The Italian delegates to this meeting try to tell their government, don't do this. Any comments against Secchi would, make a bad impression on the rest of the world, but the government doesn't listen. The government of the king cannot let pass in silence the designation made in the official French official gazette of a state that no longer exists. So he orders the Italian scientists to protest and to refuse to take part if Secchi is allowed. So they put it to a vote. The vote is to allow the representative of the Holy See to participate. The Italians abstain. After the vote, the Italians are told, well, if you don't want to be part of the committee, bye-bye. They take Secchi over the Italians. This is noticed back in Rome. This is a personal success of Secchi, but also a political achievement for the Vatican. When Secchi returns to Rome, he's met an audience by Pope Pius IX, and the Pope records, and according to Secchi's diary, the Pope welcomed me with a hand raised saying, I vote for Father Secchi. Okay, the same political upheavals that led to Secchi's banishment in 1848 continue to figure strongly in Jesuit science. By the end of the 19th century, Jesuit science is taking on this new apologetic role within the church. It's interesting because up until the middle of the 19th century, to be a scientist was a normal part of what clergy were expected to do. In a whole lot of the world, especially outside of Europe, they were the only people with the education and the free time to make and collate scientific measurements and report them back to Europe. But by the 1870s, there were a number of pressures in secular society and in the church that began to put a strain on science and religion. The idea that there's this conflict between science and religion, it started with the Enlightenment anti-clericalism, the hope that maybe science could replace religion. But the church also fed it with its sometimes uncreative and stubborn response to these ideas. And in the 19th century in particular, you had this rapid growth of technology, steam engines, electricity, this Whig myth, as we call it, of the inevitability of progress, the expected triumph of scientific thought over older ways of thought. You find that in the 19th century secular university, like in Germany. You find that in the evolving status of science as a professional occupation. It's no longer something that clergymen and wealthy noblemen can do on their free time. And most famously in Italy, the anti-clerical government, the ones that had conquered Rome and imprisoned the Pope in the Vatican, build a famous monument to the self-styled magician and charlatan monk, Giordano Bruno. In turn, they turn him into this martyr of modern science. In America, there are also anti-immigrant activities fueled by books like Andrew Dixon White's A History of the Warfare Between Science and Theology in Christendom. In this book, White argues that you have to block the immigration from Catholic nations, these people from Southern Europe and Eastern Europe, because Catholics are obviously anti-science. In fact, this led to the strong quotas and by the Immigration Act of 1924 in America, which remained in effect for more than 30 years. You know, my grandfather came before then, but they wanted to keep people like Consolmagno out of the country. And as a result of these immigration acts, immigration from Italy fell by 90% during those years. Why did they think the church was anti-science? It was not only because they were looking to replace the church with science, but I think the final test was there was this burgeoning eugenics movement. Eugenics attempted to use Darwin's ideas of evolution, which are great ideas, but they were trying to use it as the basis of breeding superior human beings and eliminating the unfit. And that was allied with social Darwinism, which, you know, tried to explain why rich people were rich because they were naturally superior to poor people. And what do you expect? We should just get rid of the poor people. When the church spoke out against eugenics as being immoral, it was labeled as being anti-science. Sadly, within the church itself, one reaction was a kind of triumphalism, a sense of its own unshakable correctness, independent and highly suspicious of developments in the secular world. And that was, you know, made all the stronger after the revolutions of 1848. And you find that in, you know, decrees of the First Vatican Council in 1870 under Pius IX. But Secchi's international repute as a scientist was noted by the popes. So after he had died and after Pius IX had died, after his observatory in the Roman College was confiscated by the government, Pope Leo XIII looked to one of Secchi's assistants to set up a new Vatican Observatory on the walls of the Vatican. It was, you know, to refute the politics of the day that wanted to make the church anti-science. It was also to insist that as a national observatory, it represented a nation other than Italy. It took part in an international astronomical project, the 18-nation Carte du Ciel, where every nation had an identical telescope, and this is ours, where they would photograph, each nation would photograph a different swath of the sky. They began doing this in 1891. By the early 20th century, the staffing of the Vatican Observatory was one of the strongest in doing this work. And at that point, the staffing was handed over to the care of the Jesuits, and the Jesuits continue to operate it to this day. Finally, in 1929, the Lateran Treaty recognizes the Vatican as an independent country, and the territory south of Rome, near Lake Albano, where the popes used to have summer palaces, are given back to the popes, where they reestablish a summer palace. And then a group of young Jesuit physicists are there, and they set up a laboratory to measure the spectra of pure meteoroids to compare against the spectra of stars. They found a journal called Spectra Chimica Acta, which is still in operation. And actually, after the war, it was printed at the Vatican. There's one other Jesuit I want to talk about before I come back to the Vatican Observatory, though. And that's Father James McElwainey. He was born in Port Clinton, Ohio, 1883, one of 8 children. When he's 15, he had to leave school to work on the family farm, but he got back to high school and then entered the Jesuit order in 1903. While he was studying philosophy in St. Louis, he showed his teachers that he had an aptitude for the sciences, and he was fascinated by the seismometer that would measure earthquakes. So he was sent for his PhD to the University of California, Berkeley. He obtained his doctorate in 1923, discussing the propagation of seismic waves on the surface of the earth, the first thesis on seismology in North America, at a university located on what we now recognize as the San Andreas Fault. But soon after he got his degree, he was sent back to St. Louis, which is pretty far from most earthquakes. But in 1925, he revived the Jesuit Seismological Association, which had a network of seismic stations at all the different Jesuit universities across America. And that kept in operation until 1963, because if you've got more than one seismometer recording the same earthquake, by comparing the time when the earthquake arrives, you can work out where inside the earth the earthquake took place. And for the first time, you're able to map out the location and the depths of the quakes. And in the process, you work out the boundaries within the earth of where is the crust, where is the mantle, where is the liquid core, where is the solid core. And the cool thing is, during the Cold War, this technique allowed people to determine the location and the strength of underground nuclear tests. And so that gave people a way of testing the nuclear test ban treaty so that we could tell whether or not the other nations were cheating on the treaty. And that's why in 1963, the operation and the funding of the network passed from the Jesuits to the American National Science Foundation. But back to McElwainey. He stayed at St. Louis for the rest of his life, died in 1956. He still worked in seismology because he did fundamental research in the lab, making tables of seismic wave travel times for different materials, different rocks. And not only that, but he recognized that St. Louis has a lot of tornadoes and even hurricanes coming up, so he also promoted studying meteorology. He had great classes, he wrote textbooks, he supported the education of a new generation of both seismologists and meteorologists. In honor of his work, 2 different prizes are named for him. Every year, the American Geophysical Union awards the McElwainey Medal for outstanding achievements by a young scientist, and the American Meteorological Society gives the McElwainey Award to outstanding students in meteorology. Today, coming back to the Vatican Observatory, we also continue to have Jesuits playing an active role in astronomy, including active in the International Astronomical Union. I mentioned my role there in naming features on planets. The chair of the resolutions committee that wrote the modern definition of Pluto as a dwarf planet was a Jesuit, Father Chris Corbally. You can see him in the center of this group. And today, there are a dozen astronomers, researchers with doctorates from all around the world, working in a wide range of fields. You may notice on this page and the next, Father Corbally got his degree from the University of Toronto. And on the next page, Father Kikwaya got his from Western Ontario. One notable thing is that we're supported by the Vatican. We don't have to worry about 3-year government grants. That means we can do projects that take way longer than 3 years to carry out, like the Spectra of metals. This is science that the rest of the field needs, but no one else can pay for. Some people call it orphan science. An example is the work that my colleague Bob Mackey and we measure the physical properties of meteorites. And I remember when I first presented some of this work, I was approached by one of the grand old men of the field who says, "Why are you doing this? Nobody does this." Well, that's why we were doing it. Because it took a solid 10 years of traveling to meteorite collections around the world to get enough data to really have a good sense of the tables of meteorite density. But that density measurements are now so important that Bob is in high demand. He's the one who knows how to do the measurements. He's a participating scientist on the recent NASA mission, OSIRIS-REx, where he's going to measure the samples that they're bringing back from asteroid Bennu. And he's part of the Lucy mission that's supposed to launch this week to explore asteroids co-orbiting with Jupiter. Let's talk then. Let's kind of review what it means to do science as a Jesuit. You can see some remarkable advantages, but every advantage has its matching cost. That Jesuit education is really beneficial, but it's also quite lengthy. You know, for a Jesuit heading towards ordination, the period of time can be, well, like 12 years. And so while a layperson who gets a PhD can be pursuing research along with grants and positions by the time they're 25, a typical Jesuit is committed to studies in philosophy and theology until, you know, maybe his late 30s. On the other hand, if you're a Jesuit, even if you're, you know, coming from a poor family, you get the education that otherwise you couldn't possibly have gotten. A Jesuit scientist can be sent to exotic and wonderful places of the world. You know, when Acosta was sent to South America, that was as rare as being sent into space. How many other scientists would have been given the opportunity to go to South America? But then the same Jesuits who paid for him to go there also ordered him to come back to Spain. This international network of Jesuits gives you a safety net. If your father's Secchi and you're kicked out of the country, you can, you know, still teach someplace else. And, you know, the fact that Grassi had Jesuits in Germany to compare observations against gave him an advantage that Galileo didn't have. On the other hand, Secchi was exiled from Rome merely for the crime of being a Jesuit. Being a Jesuit gives you instant credibility in some circles. It leads to instant dismissal in others. And as we saw, certainly in the 17th century, but even today, the expectations of the church and people's understanding of what the church is going to be can put a significant strain on how Jesuits present their work, because no matter how much you want to say, I'm just speaking for myself, Jesuits are always going to be seen as speaking for the church. And so when we present our results, it's important we do it in a way that, you know, doesn't give scandal to the church. I mentioned my own research measuring meteorites, and these here are meteorites from Mars. Meteorites, rocks that fall to the Earth. And how we know these are from Mars, it's a long story. If you're wondering about that, so was Pope Benedict, but we were able to explain it to him. I could, you know, tell you if you need to know. To measure these densities meant to have thousands of data points, 10 years. I could only do that work because I was a Jesuit working at the observatory. Not only did I not have to worry about a grant, there was usually a Jesuit community I could stay at in each of the cities where I was making the measurements or where Bob Mackey was making the measurements. At the same time, we faced the same disadvantages. Bob Mackey, my colleague, joined our meteorite lab in Rome in 2014. He's got a doctorate in physics, 3 master's degrees, most recently in theology, and he was only able to set up his lab when he was 40 years old. Finally, while none of our work has led to the possibility of scandal within the church, I am very aware that, you know, if I cut corners or act inappropriately or publish bad data, it's going to reflect badly on the church. And despite of our best efforts, you know, people are still always going to try to bring scandal to us. No, we really have not seen any UFOs, but that doesn't stop the internet from trying to tell us that. The kind of work we actually do, science that everyone needs but no one else is willing to pay for, often means that our work is underappreciated by our peers. In the 19th century, the Whig historian and politician Thomas Macaulay sneered that being a Jesuit has a tendency to suffocate rather than develop original genius. Actually, this is at the same time that Secchi was doing really original stuff, but the anti-Catholic British scientists refused to translate Secchi's work from Italian into English. This goes, however, to what it means to do Jesuit science, the motivation behind the work. You know, that statement of Macaulay carries with it the assumption that you do the science for the glory of it, to be thought to be a genius. But to a Jesuit, the glory that comes from the science ought to be the greater glory of God, the Creator. not the person who happens to have revealed some detail of creation, or worse yet, the guy who got the grant. Instead, the research itself is a form of prayer. In other words, the reason we do the science is out of love. Love of the science itself, love of the truth, love of the church who brings us to the author of the science, the author of the truth. Love of the Creator, whom we find in all created things. Thank you very much for having me here, and I look forward to hearing your questions. If you want to know more about the observatory, please look up our website, www.vaticanobservatory.org.
Thank you very much. We have a lot to ponder from your Jesuit brothers over the centuries. One of our first questions is about Lucifer. What is Lucifer, and how did Lucifer get its name?
Oh my goodness. We have a telescope in southern Arizona on Mount Graham, and it being a nice location for a telescope, there are other telescopes there, most notably something called the Large Binocular Telescope, which is one of the largest telescopes in the world, and sadly, not ours. It just happens to be on the same mountain. And it's a collaboration of a bunch of different universities, including a university in Germany. Well, some of the scientists got a grant from Germany to build a camera that would go onto this telescope. And the Minister of Education in the state that paid for it happened to have the last name of Teufel, which in German means devil. So they came up with a funny acronym that would spell out the word Lucifer. And this was supposed to be a joke. The internet, of course, just completely the human and decides that we're the people who have a telescope named Lucifer, which no, we don't. So they changed the name of the camera. We had nothing to do with it, sadly. I thought it was a very funny joke, but no.
Thank you. Where does Matteo Ricci fit into the Jesuit science history?
Ricci himself, Ricci himself, of course, was the Jesuits into China. And he was not himself a trained astronomer, but he brought astronomers with him. And I'm blanking on the name, probably someone here can remember. There were 2 or 3 notable astronomers who came, and their astronomy, including the Copernican system, was seen by the Chinese as being superior to the astronomy of the people running the Peking Observatory. They wanted an observatory to do astrology. So they handed the observatory over to the Jesuits. And for the next several hundred years, the Jesuits were actually the ones running the Royal Peking Observatory, the Imperial Observatory.
Are there any Catholic nuns who are scientists, and what would they do?
Oh my goodness. The first PhD in computer science was given to a Catholic nun, whose name, again, I'm terrible, I should know these names off the top of my head. Even at the Vatican Observatory, remember those photographic plates I was telling you about that we photographed the sky to map out where the stars are? Well, once you've got the photographic plates, then you've actually got to measure the exact position of the brightest stars. And that was done by nuns of an Order of the Child Mary at the Vatican in the early 20th century. There are any number of nuns and other members of lay religious orders who are very active in astronomy. Several of them are now adjunct members of the Vatican Observatory. If you want to know more about Catholics who are scientists, there's a whole section on our website where you can find that out, including several nuns. And of course, Hildegard of Bingen was one of the first scientists, in the 1100s, and she was, of course, a well-known Catholic nun.
Could you please show the artwork of the angels with telescopes?
Ooh, I already turned off my, but if there's a question about it, I can try to answer it.
It was just asking to see it.
Yeah, I'm.
Okay.
It would probably be too complicated to bring it back. Sorry.
What do you think of the multiverse hypothesis? Is it compatible with the Catholic faith, or is it a threat to it?
No scientific theory can be a threat to faith. As long as the theory is recognized as an incomplete, all theories are incomplete, approximation of trying to understand the truth, because the ultimate truth will never contradict truth. So, for instance, is the universe that we see all that there is? Probably not. The idea of the Big Bang suggests that there are regions of space where the expansion of space occurs so quickly that the material appears from our vantage point to be moving away from us faster than the speed of light, so we could never see it, but it can still be there. There could be parallel universes, but think of this. Genesis chapter 1 describes the best science of its day, a flat earth with a dome and water above and below the dome. And bigger than that universe is the God who created the universe. The Greeks 100 years later have now a series of concentric spheres, but bigger than that universe is the God who created it. Copernicus had a universe with the sun and then planets going around. And within 100 years, maybe other suns with other planets. Bigger than that universe is the God who created it. Herschel comes up with the idea that galaxies are island universes, and Kant suggests that other galaxies, like the Andromeda galaxy, could be different universes. Bigger than that is the God who creates it. There could be, for all we know, an infinite number of universes. And bigger than that is the God who created them all. Because our God is a supernatural God, bigger than the universe, outside of the universe, outside of the limits of space and time. And so not only bigger than any spatial extent, bigger than any temporal extent. Go back to the beginning of Genesis. In the beginning, God said, let there be light. God's already there before anything else happens. That God creates space and time. And it's up to us to figure out how he did it. And in that way, you get a little bit closer to the Creator. You get a sense of his personality. You get a sense of his sense of humor, if nothing else.
Is the fate visited upon Pierre Teilhard de Chardin an example of the delicate balance a Jesuit scientist must maintain in respect to the positions of the Church?
That's a fair statement. Chardin, I think, was brilliant at asking questions out of his science about the nature of God and creation, which other people hadn't asked. I'm not sure I buy his answers, but that's okay. It's the questions that were important, not the answers. Also, it was a different time and a different mentality in the church, a church that still felt itself under attack from the Western, the secular world, something that Vatican II changed, so that we're more in embrace of the secular world, because this is where we find human beings, this is where we find God. But I'll give you an example. The director, a couple of directors before me, an American, George Coyne, tells the story when he was studying theology. There were a number of young Jesuits who had been studying sciences, also studying theology. And this is the 1950s. And the rector of the Jesuit Studies House called all the Jesuit scientists in together to the library. And he said, "We have heard from Rome that these books by Teilhard de Chardin are considered dangerous. So we're going to take them out of the regular shelves and put them all by themselves on a separate shelf right next to the door, so that you won't be taking any of them by accident." Nudge, nudge, wink, wink.
As a scientist, what drew you to religious life and the Jesuits?
I was both a scientist and a deeply religious person when I was 4 years old, as long as I can remember. And the two always grew together. One of the hardest things I have in giving science and faith talks is to understand, why would anybody think that there was a conflict? Because I've never experienced that. And there was a moment when there was kind of a split when I was in my first year at university and trying to decide, did I want to be a Jesuit or did I want to, do something else? And when I went to a Jesuit and prayed and discerned my vocation, it became very clear, kind of frighteningly clear, I did not have the vocation to be a priest. Didn't mean I didn't have a vocation to be a Jesuit, but that took another 20 years. Instead, I felt that, where was I happy? Where was God making me happy? When I was visiting my friends at MIT, reading science fiction there, seeing the cool experiments there. So I moved to MIT and became a scientist, but I never stopped being a deeply believing person. I never stopped wondering about what I wanted to do with my life. It was only in my late 30s that I finally came to this crucial decision. I was teaching at a little school called Lafayette College, and I was phenomenally happy. I knew that I wanted to teach. I knew that I liked the idea of being at a small university or a small college. At that point, I'd just broken up with a girl I'd been dating, and I'm trying to think of, what do I do with my life now? And nobody's listening, right? I'll tell you a little story. So I'm, 38 years old. I'm wondering what to do with my life. And I do this mathematical calculation because I'm a nerd. You do math for everything. I said to myself, okay, so what if tomorrow I met the perfect woman and we get married? By the time we would start a family, I'd be 40 years old. Isn't that kind of old for a family? Those kids would be teenagers and I'd be 65, way too old. So pondering what else to do instead, I suddenly remembered once encountering a PhD in history who was a Jesuit brother. And the more I thought about this and the more I prayed about this, the more I felt called. Yes, I could enter the Jesuits and teach at a small Jesuit college and be a brother. I entered the Jesuits. I discovered this is where I should have been all along. And then one of my Jesuit friends heard this story and goes, Guy, 40 plus 15 is 55, not 65. I entered the Jesuits because I didn't know how to add two numbers. And what's more, instead of teaching at a small college, the Jesuits made me take this vow of obedience. And under obedience, I had to, move to this ugly palace in Italy with that terrible scenery and, that boring food. And yes, 1,000 meteorites that I could make measurements of. But I had to obey. So here I am.
Thank you. Tell us about your book, Would You Baptize an Extraterrestrial? This is probably not the actual title.
Oh, it actually is the title. We're going to put in a subtitle and all the other stupid questions people ask us, but the publisher said, no, don't say that. The important thing in science is to ask questions, not necessarily think you're going to get answers. It's in the process of exploring those questions that you come to understand things that you thought you understood until you started poking at them more. And so when people ask me the question, oh, you're an astronomer, you like science fiction, so are you out there to baptize extraterrestrials? Would you baptize an extraterrestrial? My answer, my flip answer is, yeah, only if they ask. But then you go, what does baptism actually mean? What does baptism mean for some entity that has a soul, but, isn't a human being? What does a soul mean? Intellect and free will, says Thomas Aquinas. What's intellect? What's free will? Does any entity that have intellect and free will has a soul? That means they're made in the image of likeness of God, just as we are. Then what would make them aliens? What does it mean to be an extraterrestrial? Just, we happen to be born. Asking questions like that makes you dig deeper into the assumptions that we sometimes make without thinking about our faith and how our faith works. And so that book goes into not only extraterrestrials, but lots of other questions that we do get asked, from the origin of the universe to the end of the universe to the Star of Bethlehem to lots of questions that are fun to ponder and don't necessarily have an answer that you wrap your hands and say, got it, put it in the back of the book. That's boring. Don't look at it anymore. That's not how science works.
Thank you for the historical overview of the Society's contributions to science. I am curious, in addition to the scientists of the observatory, how many Jesuits or what percentage of Jesuits do you estimate pursue scientific endeavors, and how does this compare historically?
I would say there's probably fewer now. I mean, there's only a dozen of us at the observatory. As people who are actively research scientists publishing in their field worldwide, I'd guess maybe a few hundred, and some more in some countries than others. Part of it is that science is now a field where people can make a living doing it. You don't have to leave it only to the clergymen who are already being supported, because pure research doesn't pay. It's not going to make you rich. It's not going to make you famous. It's not going to make you powerful. It's not going to get you girls. At least, it didn't work for me. So you do it out of a sense of love, but that's a real luxury to be able to do that. And yet it's a luxury that I think is important, that everybody should have at least the opportunity to ponder the universe. Think back to the Genesis 1. That first chapter of Genesis, the best science of the day that was going to be obsolete within 100 years. The part that's different from Babylonian science, the part that endures even as the scientific descriptions change, is not only that we've got this God outside of nature who deliberately creates and creates out of love, but the ultimate goal of creation is the seventh day, the Sabbath. The time when every human being is given a chance to contemplate the universe, to ponder it in your heart, whether you're doing that as an artist or someone who likes to run or someone who likes to swim or someone who likes to look at stars. To become immersed in God's creation is a way of becoming close to God. And that's something that we are all called to do.
What is your favorite science fiction work?
Ooh, do I dare admit it? There are some very profound books out there, but I do profound for a living. When I read science fiction, I'm looking for popcorn. I'm looking for fun stuff. There's a Canadian writer who I'm very much a fan of, Jo Walton. She is up in Montreal and has written some marvelous books. But I have to admit, I really enjoy goofy space opera. There's a husband and wife team, Sharon Lee and Steve Miller, who, every time a book comes out, I'm sure to grab it. And I'm just going to enjoy it because it shows me a bigger universe than I'm used to living in. And it reminds me that the universe is bigger than the flat earth that I see around me. And it's a place where people have fun. This is a universe to have adventures in.
What do you think are the advantages and dangers posed by artificial intelligence?
Well, to begin with, it's a terrible name for a really interesting thing you can do with computers, but it has nothing to do with intelligence. 50 years ago, when I was a student at MIT, my college roommate, worked in the artificial intelligence lab with Seymour Papert. I got to know him. I got to know Marvin Minsky. Marvin Minsky's daughter is a friend of mine. These are some of the big lights of artificial intelligence. What artificial intelligence as a computer algorithm does is it does really clever things, but it's not the same thing as human intelligence. Could we ever produce intelligences with souls? Every mother and father does that. Of course we can do that. The question is, will we respect any entity that has the ability to recognize and be aware of its own consciousness and the freedom to make choices to love or not to love? And those crises are with us regardless of how that entity was created or where that entity was created.
Could you share some examples of orphan research that Jesuits are pursuing or have pursued? It's a fascinating area to hear about.
One of the most profound, something I didn't even get to because there's so many examples. When Westerners came to India and they started doing systematic science, I mean, the Indians are phenomenal at mathematics, but a culture that doesn't believe in a creator God is less likely to give resources to measure, creation itself, rather than the more spiritual and the more philosophical ideas of mathematics. So it was up to Jesuit priests to go through the flora and fauna of India. Now, if you want to know from a leaf, what tree is this? What do we call that tree? Who named it? These books were put together in the 19th century by a series of Jesuit priests. And that was work that no one else could have done because it was such a massive undertaking. No one else could have afforded to spend the resources to do it. And the culture at that time hadn't thought that, oh, this might be a worthwhile thing to do.
Can you say anything about the Italian Jesuit called Father Typhoon in China? I think his name was Ricci.
That particular name, I don't know. I do know, and there's a book by Father Udias about Jesuit observatories, that when Jesuits went in mission territories, they would often set up a telescope or a seismometer or very certainly a weather station. And because of the network of Jesuits, they began to be able to understand how weather moved from one place to another. So the ability to predict the weather, such as typhoons, would be something that the locals, for all of their advanced philosophy and all of their advanced mathematics, hadn't bothered to do before. And so I'm sure that's where a nickname like Father Typhoon would come from. But that particular priest, I don't know the details of.
I've got to ask, how did you determine that those meteorites were from Mars?
I'm glad you asked. I set that up just so somebody would. In any scientific determination like that, you want more than one line of evidence. You want more than one reason to believe that, from Mars, that's a pretty crazy thing to believe. Well, the first thing you notice about these meteorites is that chemically they're 1 in 1,000. They are chemically different from all the other meteorites, and all the other rocks that fall from space through the atmosphere, hit the ground, have metallic iron. They've not been rusted by our atmosphere. These meteorites are also seen to fall from space. They've got the burn marks on the outside, but the iron in them is already completely oxidized. They came from someplace different from all those other meteorites. That's strange. What source do we have out in space that has an atmosphere that might be oxidizing iron? The next thing you notice is when you measure the age of the minerals, how long have radioactive elements been decaying in that mineral since it crystallized? You know that all of the meteorites, with the iron in them, are 4.5 billion years old, which we think is also the age of the Earth. Moon rocks are, generally no younger than 3 billion years old. But these rocks are, some of them, as young as 100,000 years old. The bigger the planet, the longer it could hold its heat. So these meteorites had to come from a planet that was bigger than the moon and had an atmosphere. And there's not too many rocky planets that could be. Mars and Venus are the only other two ones out there. And it's really hard to figure out how you could get a meteorite off Venus because it's so big and the gravity is so strong. And then you got the gravity of the sun to overcome. So by elimination, it looked like maybe Mars was the source. And then a meteorite was found in the Antarctic ice sheet that appeared to have been cracked, as some shock that lifted it from wherever it came from caused the meteorite to crack, and where it cracked, it melted, and where it melted, it froze into glass, and where the glass froze together were tiny bubbles of air from whatever planet it came from. So You take this rock, you carve around one of those bubbles. You put it in a thing called a mass spectrometer, which is a total vacuum. You melt the glass, the bubble pops, all the gas in the bubble goes flying through the mass spectrometer, and you count atom by atom by atom to find out what's the composition of the gas. And the composition matches exactly, both in chemistry and in isotopes, the atmosphere of Mars. So how many planets out there are the size of Mars and have the atmosphere of Mars? Well, how about Mars?
Could you tell us a little bit about your research in Antarctica?
I went as part of a group. Every year, there's a group of 6 or 8 scientists who will go to Antarctica for a month to collect the meteorites off the Antarctic ice. Now, meteorites fall everywhere. You probably heard about the meteorite that fell in British Columbia last week. They can fall anywhere, but unless it lands in some woman's poor bed, if it landed out in the street 20 feet away, you'd never find it. Because first of all, it looks just like any other rock. And secondly, remember how they're all made out of metallic iron. As the iron rusts, the rocks fall apart. But when a meteorite lands in Antarctica, number one, it's kept frozen so it doesn't rust. Number two, the ice actually moves the meteorite to the front end of a mountain range so that all the meteorites that fell upstream of that are all concentrated right in this one region. And the meteorites are black, but their ice is white. So it's really easy to find them. So every year, people go to a different region of the Antarctic ice sheet, live in tents for 6 weeks, go out every day on a skidoo and go out and collect the meteorites, put them in little baggies and send them back to Houston to be analyzed. In the process, it was like living on another planet. And as close as I'll ever get to living on another planet.
I think we just have time for a couple more questions. Why do you think that the church still suffers from the misconception that it is anti-science in popular culture?
I think this misconception continues because it's worth it to somebody to keep it going. Ask yourself, who are the people who are promoting this story and what's in it for them? An awful lot of popular science is promoted by people who are busy promoting themselves. And they want to say, I'm smarter than the rest of you because instead of believing in that old ancient religion, I've got this new religion of science. Well, science makes a terrible religion. Actually, religion makes it a pretty lousy science too. They aren't the same thing. But I think it's still too much in the ego of the people who are trying to promote themselves as spokesmen for science to want to promote this myth that, and people who want to think themselves as cleverer than the rest of us. Oh, you people believe in religion, but I'm smarter than that. One of the weird things that happened to me when I became a Jesuit, I'd been a scientist for 20 years. I become a Jesuit, I'm wondering, all right, people know I go to church. What are they going to think? So many of my scientific friends came to me and said, you go to church? As if, my behavior didn't show it, I guess. Like, you go to church? So do I. Let me tell you about the church I go to. If you want to go to a college campus and find atheists, you don't go to the science department, you go to English literature.
What do you think Stephen Hawking was missing concerning the existence of God?
He had a bad idea of what God was. And the God that he didn't believe in, I don't believe in either. To be an atheist, you have to have a really clear idea of who God is. Otherwise, how do you know that you don't believe in that God? You also, to be a believer, you have to be open to the possibility that it could be true. And when you get a bad science, when you get a bad religious education as a young person, that can turn you off the idea of religion. Just as if you get a bad science education, you can be turned off for the idea of science afterwards. So I think the role of parents and the role of teachers in showing our students, showing our younger people that both science and religion are not closed books of facts, but open notebooks where we're continuing to write the book, continuing to add new pages, continuing to refine what we understand and say, that was true, but, which is what we do in science all the time. You know, if we didn't do that, we have no reason to ask for a grant to do more science. And that's also what we do in religion all the time, where we wouldn't keep praying if we thought we already had God figured out. In both cases, you have to remember that a scientist's affair with the physical universe, a religious believer's affair with God, is an affair of love. And love is constantly growing and constantly getting deeper. If you think of your spouse as a problem to be solved, that's not a very, very loving relationship. But if you see God and you see the universe as lovers to be constantly amazed by and filled with joy by, then you will never exhaust the possibilities of learning about God and God's creation.
And one last question. We recently lost John Polkinghorne, an Anglican priest and theoretical physicist. He attempted to make connections between our scientific understanding and Christian theology. Do you have any favorite or recommended books that you think succeed in making coherent connections between science and theology?
Well, of course, my books, they're so good, everyone should go out and buy 3 copies of each one. No, to be more serious, there are good books out there, and our website actually reviews a number of different sources. So if you go to the Faith and Science resource on our website, you'll see a list of a number of the books that we think work. But the book that works for you might not work for your neighbor. It depends on where you are, what your assumptions of the universe are, where your questions are. So it's an individual taste. It's almost like asking what's the best science fiction novel. It depends on what you're interested in at any given moment. But there is a lot of good stuff out there. It's also a lot of shady stuff as well. So it's good to have somebody who can maybe point you in the right direction.
Thank you. Guy, it's my pleasure to thank you on behalf of the Jesuits of Canada and our audience tonight for your very interesting and challenging presentation. I'm sure for many of us, as it was for me, the history of Catholics and the Jesuits in particular, and their contribution to science is something that we all need to study a little more deeply. You've opened up numerous possibilities of subjects and topics that we need to explore further on our spiritual journey. So thank you very much for being with us tonight. I also want to thank Jose and Fanny and our translators, Albert and Michelle, who ensured our presentation ran smoothly. And I would like to thank our audience for being with us. A reminder, our next webinar will be with Father James Martin on November the 2nd, Building Bridges, the Catholic Church and the LGBT community. And I'll turn it over to Jose for our final word.
Yeah, but first to Brother Guy, anything you wanted to say? Notice you raised your hand for a second.
Well, I was just waving in thanks. Thank you very much for having me. And I apologize if I spoke too quickly for the translators at times, but when I get excited, I forget. I hope they were able to keep up.
Yeah, and just a few more seconds, couple reminders. The first one is that you should watch out for the recording of the webinar, which will be shared with you between 24 and 48 hours after tonight. And also remember to fill out the brief poll that will pop on your screen at the end of the session. If you don't catch it at the end of the session, it will be sent to you via email too. So thank you so much.
Thank you. And Guy, I know you'll be coming to Canada within hours, and we wish you every success on your trip here.
Thank you very much.
Thank you again.
Bye-bye.
Good evening.